Hello students, welcome once again to Dr. Soros's classes. We are back again with group theory, and I know some of you all are feeling a little bit dizzy around when the video starts of group theory. Okay, but the concept, I know it's the concept is a little difficult to understand, but if you try hard enough, okay, if you go ahead and if you study hard enough, you know nothing is difficult. Study is not equal to difficulty. It's something like that, okay, made up on my own. Okay, so students, today's topic we are going to talk about the centers of some important group. If you remember, in the previous video we spoke about the center of a group. If I go back to the previous slide that I had done for you in the previous video, here it is, the center of a group we had spoken about, and we also spoke about some results on the center of a group. You can see on the screen there is a lot of scribbling on the screen, but all this scribbling was explained to you in the previous video. I'm sorry, not video. Okay, today we will talk about the center of some important groups. Okay, and you can see it's vaguely just written over there. That's because I need to explain to you what is that. Okay, it's just vaguely written. Okay, you don't have to worry about the explanation also, because they are just simple. Okay, so let's start. Let's just rub off what I had written over here, and let's start with this. In the first one, you have Z of Zn is equal to Zn, centers of some important groups. So this group's center is Zn. So Z of Zn's center is equal to Zn. Next, Z of Z's center is equal to Z. Z is integers. Okay, now next one, Z of Q, Z of rational numbers. All right, Z of natural numbers, okay, is equal to why, you know, one thing I would like to tell you, okay, this is not a Z of integers, okay, because they have written it like that and I'm carrying on saying integers. It's a Z like this, okay, it's a normal Z, okay, and that one is integers, the inside one is integers, okay, and this is this ZG is actually the center of a group. ZG is always a normal subgroup of G, okay, so this is a normal subgroup of of integers whose center is Zn, okay, whose center is the integers Zn. All right, so this is not integer, okay, this Z is not integer, please, these ones are not integers, these are showing normal subgroup, all of them. All right, so they actually don't know. Even in this, did I say anything as integers? All of them. This will Z. Okay, this is going to be. Wait, one second. Yes, students. In the previous video also, these Z's are not integers. Okay, why they have written it like that? I don't know from where they had written it like that. These are all Z's means, ZG means center of a group, okay, center of a group, ZG. Yeah, and that was also there. That's where they made the mistake. The mistake started from here, okay. This is not integer Z, this is the center of a group ZG, okay. That's not the integer Z. The integer Z is different, okay. So this means the center of the center of the center of the center of G is equal to just the center of G. and this also is the center of G. G divided by the center of G is cyclic, then G is abelian. Okay, this is also the center of G. ZG, if the center of G is equal to G, G will be abelian, the group G will be abelian if the center of G is equal to G. So please make some changes. These Z values are not integer values. So that's what I was thinking even here. Okay, all these Z values are not integer. Okay, that's what I'm thinking. How are they right? How is it written at integers of G? That's not possible. Okay, anyways, that is an integer. Okay, this one is an integer. Now, center of rational numbers, the center of the group of rational numbers will be, its center will always be the rational numbers. Okay, Q. Next one. So please students, make the changes. Okay, you already know that ZG is the center of a group. Did I write the ZG here also properly? Yeah, it's okay. Here I have corrected it. Okay, so please make some corrections. Sorry about this, because the people who are writing the people who are making the slides, right, they don't know about group theory and all, so they are just making what they have, the material in front of them, or whatever new fresh material they have, or we are giving them. So sometimes in the writing part, when we write, you know, when we write Z like this, and then we write Z like this, so they are sometimes confused what is the meaning of this and this. So we cannot explain to them the mathematics, but we can make the corrections here. Okay, so if you find anything that is over there is a mistake, when the videos are uploaded and you're watching the videos, you can just comment over there. So then what happens, we will do the corrections, and we will let you know. Mostly there will be no mistake, because simply because what is happening, we know what's going around here. But sometimes there might be mistake, because what is written over here, I'm looking at, and I'm trying to explain from the screen. So sometimes we are bound to make a mistake, because what's written in the screen. Okay, sometimes what is happening, what happened here is, what was written on the screen, it was not matching with the logic. Okay, so that's how it is. So that's why I needed to correct that. Okay, anyways, the center of the group of rational numbers is rational numbers. Center of group of real numbers, Z of real numbers, center is just for real numbers, and the center of the group of complex numbers will just be equal to the complex numbers. Now, what I want you to know is that all the above groups, all of them, just hold on, all the above groups are, what they are saying, all the above groups are also abelian under addition. Thus their center is a group itself. Okay, so the centers are group themselves. These centers are groups themselves, are groups. Okay, now what they are trying to say, all the above groups are abelian under addition. So they are all abelian under addition, these ones. Okay, so the centers are a group itself. Okay, moving on to the next part, students. In the next part, what is happening over here is that in the next part they have given us a slide which says mathematical notes. So over here I'm going to explain to you some of these center of groups, okay, which are given in mathematics. Okay, so let's start with the center of the groups which are given in mathematics. Okay, so the first slide we will do with a different color, blue. Okay, say if a group G is equal to, is a group of general linear group, I would like to take that only, of real numbers. Okay, general linear group of real numbers for n greater than 1. Okay, now from here, comma, then what happens is, what was it? It was ZG will be equal to, it's a matrix format, okay? ZG is equal to the matrix A, and the matrix is given such that it's A 0 0 right on till 0, then you have 0, then you have A, then you have 0, okay, then you have 0 0, then you have A, okay, like that. Okay, now if you continue from here, you'll go on to 0 here. Let's rub out that. I got to extend that, yeah, got to extend that. So here we go. Alright, so we're going to get 0 going down this way, and this way if you go, it's a 0 right on over here. Last one is going on diagonally like this. Okay, so if you continue from here, you'll get A here. Alright, that's the matrix. Don't write like I have written, okay, and of course A will not be equal to 0, okay, and A will belong to the real numbers. So this is ZG. This will be the center of the group. If G is equal to some general linear group, okay, of order n of real numbers such that n is greater than 0. So what is it trying to say? What is it trying to say? It says that if G is equal to some general linear group of order n with real number r, okay, with real number r such that n is greater than 1, then the center of the group of ZG can be found in this way. A is equal to the matrix A in the diagonal way. You continue right on till A here, and everywhere else is 0. But A should not be equal to 0, mind it. Okay, A can be any real number but cannot be 0. Okay, it's over here, it's written over here, A can be any real number but A cannot be 0. So make sure don't write A is equal to 0, because if you write A is equal to 0, you are bound to make a mistake. And there is more to this. And order of Z of G L N of R is equal to infinity. So what is the order of this group? It's of infinite order. Order of the center of this group is of infinite order. Okay, it will continue on and on and on to infinity. Okay, so the first so this example is very, very vital, students. What I want you to do is go through this example. All right, very, very vital point, very, very important example. Okay, so in this video, what did we learn? In this video, I spoke to you about the centers of some important groups, and I made some corrections over there. How Z of integers of n is equal to Zn of order n. Okay, then Z of integers, the center of group of the integers is equal to the integers. Center of group of the rational numbers is equal to rationals. Center of group of real numbers is equal to reals. Center of group of complex numbers is equal to complex. All the above groups are abelian under addition. So we have learned many things today, right? We learned many things from here. Then one beautiful example, one beautiful and important example, of course. It's where it's important. So if there is a general linear group G, okay, of real numbers of order n and n greater than 0, and this will happen. So this is the center of the group in matrix format, where A is the matrix, and the order of the center of the group will be infinite. You might want to concentrate on this one. Okay, so that's it, students, for today. We shall continue with this video with this chapter or part of mathematics. in the next videos. You keep taking as much help as possible, because all the help that you will be needing will be provided here at Saurabh's class. Thank you for watching, students. See you in the next video. Bye bye.